Hello everyone. So now we are going to see that the course beyond the curriculum. Course title is that advanced linear algebra from eigen theory to modern statistical learning. And this is Kavita, and we are going to see that the day of CBC class 2. And here we are again seeing that the correlation. The first one, the syllabus is containing like this, already explained in previous class. So chapter 1, correlation and regression, and chapter 2, introduction and to vectors chapter, and 3, solving linear equations, and the next orthogonality and eigenvalues, eigenvectors. Sixth one, singular value decomposition, and seventh, linear transformation. So let me will continue with the correlation. So here you can see that. So review for this. Yeah. So now you can see that I'm examining the differences in the mean between the groups. Here you can see that how many independent variables are there. So one we can take that one and more than one also. If you are come to that this one and how many groups are there? There are two or more than two like that. So you don't know about that what the independent variables will be that, and more than two also we don't know. You can see that the relation differences or the relations ships like where we are using that these more than one or more than two like that. So here I am going to tell about that here. So for these t-test and ANOVA we are going to take, and here you can see that correlation regression analysis. When we are using the t-test and ANOVA, so is we are examining or I am examining the differences between the groups. Then we can use that these two types of the test. And here we can see that when we are examining or are myself examining that between the variables, and now we can see that the correlation regression analysis. So this is very important when we are going with that the correlation regression in stats, and so this undercomes to the test of hypothesis. So this here we are seeing that the groups, and here we are seeing that the variables. Next, come to that actual part. What is a correlation? So, as you know very well about that, the minimum knowledge about the correlation. So that's only I'm going to tell about that with a small definition. Correlation is a statistical measure that expresses the relation between two or more variables. And correlation is typically represented by correlation coefficient, which is a numerical value from -1 to 1. And we can see that the examples demand and supply and height and weight also. Come to that introduction part. In the introduction, correlation measures the relationship between two variables and widely used in especially data analysis in engineering, and helps in prediction and modeling also. Now come to that exact definition. Correlation is statistical measure that explores that extent to which two variables are especially linearly related. And come to the three conditions of correlation problem. Fine, that means here the R will be there. We can call it as a correlation coefficient, especially. So, which is strength that linear shape between the two variables. And if you are having that one variable, and we can say that which is a strong variable, and 0 is no correlation between those two variables. If you have that R is very near to -1, then which is a negative correlation shape. And come to the assumptions of the correlation. The two variables need to using the continuous scale. The scale will be in a continuous mode. The two variables of interest should have the linear shape, which you can check with the scatter plot. Yes, for coming next the classes, we are going to see that the types of methods also. There we are going to see that the scatter plots also, and there should be no superior outliers. The variable should be normally or near to normally distributed. And come to that the solid examples, and now you are going to see, we are not going to see that all these, but I have given that the examples. Survey was conducted in a city, then the sample example taken that the 8% age and the corresponding income. And research objective also we can see that to find the effect of age on income of individuals. And here we can see the null hypothesis based on the correlation. There is no significant age of the income of individuals. Alternative, which is represented with a H1. So against that the null hypothesis we are going to see there is a significant effect of age and an income of individuals. And now we can see that the solution how you are going to solve by using that the correlation. So the x values we are putting here and y values income also we are putting, and now we are taking that with the mean of x minus x bar, and the same income also y minus y bar, and taking that x square y square values by tabulating these data into the tabular form, and we are getting that x bar value is this and y bar value is this. And this is the formula where you are going to here x bar and y bar in a fraction mode. So that's the reason we are supposed to use that the correlation coefficient. We are finding that the differences between the two variables. So this is the formula we are going to use: summation of xi minus x bar, yi minus y bar under root of that xi minus x bar whole square, summation of yi minus y bar whole square. And after calculating all those things, you are getting that 0.231. So this indicates that it's a very weak correlation between that the age and the income. So like that, we are going to find out that the values. And one more example also we are going to see that here that in real time, so the same data also we are going to use that in SPSS data analysis. What is the meaning of the SPSS? No, it's nothing but the statistical package of social science. So whoever not in a technical perfect, so those people we can use that so these software, and we also get that the same thing. We can find that the same 0.231 by using that the software can get that all the p values. Moving on to that importance of correlation, so it measures the degrees of correlation, whether it is a positive or negative. So that's what you are going to see that in the previous example, we got that positive correlation, but in a weak mode. Now we can see here, if it is a fundamental in many scientific and research studies, helps in understanding economic behavior also. So that's the importance of the correlation. Now correlation cause also you have to see that, but it because correlation when you are knowing about that causation also it's very important. Now we can see that we want to know how two variables are related to or overlap with each other. That means the both how they are making that the how much strength will be there. So then we can see that if one variable causes the other, it will be correlated with that. However, some correlations are superior and association does not automatically mean causations. So this last line you can remember forever. And limitations of correlation coefficients. Now we can see that here they tell us how strongly two variables are related and may capture causations between. That's what previous slide shows that, but cannot differentiate from superior ones. And however, are that means coefficient of correlations are limited because they are cannot tell about anything about that. That means marginal impact of x and y directions of causations when present. Forecasting also we can take that the thing because we can't find out that the based on the what's exactly we are taking in the morning, we are taking in the afternoon, we are taking in the evening, and we are taking in the finally in the by night 12 o'clock, right? So based on that only we are making that all the variables and getting into that the result, right? So like that. So because of the above, ordinary least regression analysis is most useful. And adding on that these two also, correlation does not imply causations. That's I'm telling that again and again, and only measures linear relationships. And examples, a few more examples also I'm going to keep here. Examples of correlation: is there any association between children's IQ or parents IQ? So nowadays you can see that the Gen Z and all we are going to see that, no? So that based on that example I need to put on you in front of you, because you have to know about that how the correlation will be affecting in that. So degrees of social trust and number of membership in a voluntary association, urban growth and air quality violations, and GRA finding of number of publications by PhD numbers, students, number of police patrol and number of crimes also, grade on exam and time on exam also. So these are all you can see that one variable to other way, x and y, x and y, x and y, right? So we can see that how much strength on that, right? Advantages, easy to compute and helps in prediction, useful in research and modeling. So with that, so all the introduction part of the correlation is completed. Now we can see that applications of the correlation, engineering, mathematics. So in engineering, system analysis also we are going to use, and load and deflections in the structures, voltage and current in electrical circuits also, temperature and pressure in thermodynamic systems also we are going to use. In signal processing, especially used to compare signals, radar signal detection, audio, video, image processing, noise reduction in communication systems. And machine learning and AI, future selection in data sets and identifying relationships between variables, predictive modeling, and used in intelligent and engineering systems also. Come to that quality control in the manufacturing, process temperature versus product quality, machine speed and defective rate, materials composition and durability. Structural engineering, stress and strain relationships, load and deformation in bridges, wind speed and building vibrations. Environmental engineering, rainfall and groundwater level, and pollution versus health effects, temperature and climate change patterns. When come to the transport, that means civil engineering also we can see that here, traffic density and accidents rates also, speed and fuel consumption, road capacity and congestion. And come to that biomedical engineering, heart rate and blood pressure, sorry, medical signal analysis, disease prediction and using patient data. Advantages of the correlation, other than that what previous slide tells about that, it helps understand the relations, supports prediction and modeling, and useful in research and data analysis. Come to that, especially we are focusing on not the correlation, we are going with that the only the taking that the correlation coefficient which is represented with this r, right? So correlation coefficient is nothing but the statistical index of the degree to which two variables are associated or related. We can determine whether one variable is related to by another by seeing whether scores on two variables are covariant, whether they are vary together. Now the values of previous slides also I told you that plus one, minus one, weakly correlated, positively correlated, and I mean negatively correlated. That's what I are going to see. If plus you are getting that value perfect positive, negative you are getting negative, perfectly negative, and zero you are getting no correlation. Now types of correlation. So these are all the things. On the basis of degree, positive, negative, nana. And then on the basis of variable, simple, partial, and multiple ma. On the basis of linearity, linear and non-linear. So these, see, you can't tell about that always positive and negative, right? So the types of correlation on the basis of what degree are, then you can. On the basis of variable, then you can. On the basis of linearity, then this, like this you have to see. And come to the types of correlation, positive, negative, zero, perfect correlation. Next, positive correlation. Both the variables increased or decreased. Then you can say that positive correlation. Example is load and deformation. Negative correlation. When one variable increases and while the other decreases, then speed and travel time, right? So you can see that both positive and both will be the negative. So here you can see that here the positive and here I kept that negative, right? Now come to that zero. There is no relation between both. Shoe sizes and exam marks. There is no relation between what's the shoe size and exam marks, right? So zero correlation. So the picture I kept here to better to understand that the examples and the values also I kept here to get that more connectivity between the correlation and correlation coefficients, right? Next, rules of thumb. It's not required, but you can see that here also. Whenever 0.8 to 1 will be there, very strong. 0.6 to 0.6 will be there, very. This is strong, and this is moderate. Just in the first, third slide or fourth slide, we got that value is 0.2, right? So I said that weak. How I know that? Because based on the rules of the thumb, right? The strength of the correlation depends on how many data points in the scattered plot are very near or far in the pattern. So this is similar to the error in the data which comes from the other explanations. Okay. So here is the linear relation between x and y. This is a positive, right? Because the both are moving in a positive direction, right? And what's that relation you are seeing here? Both all are getting into that the down, right? Then strength of the relationship, the magnitude of the correlation indicated by numerical value, ignoring the sign, and express the strength of the linear relation between the variables. Now you can see that here 1 and 0.4, 0.8 and 0.17, right? Methods of correlation. That's what I said. No, so when the correlation will be there, you are going to see that scatter plot, and then Carl Pearson method and Pearson method, or we can say that the rank method also. Okay. scatter plot, general graph that from childhood onwards we are going to see that here. But anyway, we can discuss that very lightly here. The relation between any two variables can be portrayed graphically on x-axis and y-axis. Each subject's I has x and y and scores the entire sample are plotted. The results is called scatter plot, right? And this is the scatter plot showing this graph. And now we will move to the Carney-Pearson method. And for the first example, I showed that one problem. No, so that's when x bar and y bar, the mean values you got the fractions. You are going supposed to use that the summation of xi minus x bar into yi minus y bar in a numerator, and the denominator as a square root of summation of xi minus x bar whole square into yi minus y bar whole square. So these are all the things we can see that. And the correlation coefficient when x, y are fractions. That's what I said. That is okay. Then Carl-Pearson correlation formula. Sorry, it's already over. Next, Pearson correlation coefficient. So the same like that, but here I'll show you that the formula. There are many kinds of correlation coefficients also, but this is the Pearson correlation coefficient. See, the values are all they will be the same. Now in the same part only we can see that the linear relationship also correlation involves linear relationships, so that's the main thing. No, the linear refers the fact we graph of our two variables and there is correlation, we get line of points, and the correlation tells how much you two variables are linearly related. That's you can see that here. Next, coefficient of determination will be r square. The percentage of shared variance, you know very well variance, right? Sigma square, like that we are s square, we are representing in a stats node. So the similar way here, a square of the correlation coefficient. Variance indicates the amount of variability in a set of the data, whatever the data you have taken. Two variables are correlated. That means that we can count for the sum of the variance in one variable by the other variable, like this determination. Statistical significance of R. So here statistical significance is nothing but this is the null hypothesis, this is the alternative hypothesis, right? Here also just previous slides also we have seen that the causation the same thing, but in the correlation with like taking that x and y, whether causation is there both the variables or not, like that. I don't think that always the causation will affect the data sets. No, no, you have to see that whether it is there or not. In the class, I explained that more about that the causations and all these by taking that classroom examples. No, that also we can get into that the part, right? So come to that final part, conclusion. Correlation is an important statistical tool used by the engineers to analyze the relationships between variables and make the data-driven decisions. And one more conclusion, correlation is a powerful statistical tool used by engineers for analyzing relations between variables and make data-driven decisions, right? So here also the tells about the same. It ranges from -1 to 1. One indicates positive, -1 indicates negative, 0 indicates no relation. So hope any questions from your end, you can if not here, you can text me or in a WhatsApp group or mail me, or you can respond that by call also. You can do that. So this is the quotes behind the syllabus. Thank you so much. Thank you so much, girls.